Okay, good morning class. Alright, we're back. So, we're looking at exercise 3, dealing with 2D and 3D problems, okay? And this is on page 126. We are told in exercise 3 number 1, the figure represents the top slope, the top of a sloping school disc. So these ones you have here, you see? That is not straight. Can you see it sloped? Yeah, the line. Top of the school disc. Now, A, B, C, D represents the horizontal plane, so the flat plane. We assume now this is the ground. Okay, flat on the ground. So ABCD represents the horizontal plane with dimensions 60 centimeters by 40 centimeters. Okay? ABFE represents the sloping disc top, the top part of the disc. Calculate the angle between the horizontal plane, which is this angle here, the horizontal plane, and AF, the diagonal of the sloping disc top. If BC, this angle here is 15 degrees. Okay, so where do we start? We start by saying, okay, what triangle can be formed with this here? You can form triangle AFC. So what you should see is this here. So AFC. What's the size of this angle? 90. This angle? Theta. What else can you calculate here? In this triangle? I can calculate AC. How are you going to do that? Pythagoras coming from the plane here. So let's go here. What type of shape is this? A, B, C, D. It's a rectangle, not so. So this is all 90. Okay, so this is going to be A, B, C, D. I want to calculate AC. This is 60 and this is 40. How are you going to calculate AC? Pythagoras, yes, well done, everybody at once. 40 squared plus 60 squared. You get 40 squared plus 60 squared. 5,200, the square root thereof is 20 root 30. So that is 20 root 30. So what else do I need in order to calculate this angle? I need to calculate FC or AF. Which one of the two can be calculated at this stage? Sorry? FC. How are you going to calculate FC? We look at the FC. What do I have? What's the length of BC? 40. The length of FC is what we want to calculate, because that's in that triangle as well. This is the triangle I'm working with. And what's the size of this angle? 15 degrees. So I'm going to calculate, and the size of C? 90. As you can see, that's again 90 to the horizontal. So which trigonometry function is this? Opposite and? Jason, which is? 10. So tan of 15 is equal to FC over 40. Over 1, cross multiply. So FC is 40 tan 15. 40 tan 15 gives us 80 minus 40 root 3. Or you could have written is decimal equivalent. Okay. Now what? Plus. Now what can we do? You would work out this angle by saying that is your opposite and adjacent. So which trigonometric function is that? So So tan of theta is equal to opposite, which is 80 minus 40 root 3 over 20 root 30. So theta is equal to arc tan over. So arc tan, we shift tan, the second function tan, answer over 20 root 3. Let's check the answer there quickly. 17.19. 17,19 degrees. As you can see, the slope is fairly shallow, gentle, not so. Is that correct? People for homework, I would like you guys to conclude exercise 3. There are 7 sums. That's wrong. What is the answer? Eight comma 45. Okay, I will check now where I went wrong. Otherwise, I'll just redo it on my. Enjoy the weekend. For homework, you must do exercise 3. Alright. Okay, good morning, class. So, today we're looking at problem solving in 2D and 3D cases. 2 dimensions and 3 dimensions. On Friday, you guys said that this answer here did not correspond with the answer in the textbook. Not so. But what my mistake was, when I entered this into the calculator, I entered this as the square root of 3 and not the square root of 13. Okay, so when we say shift tan of 18 minus 40 root 3. This is a line of root 3. What do you take? Alright, so that is 40 root 3, and that's over 20 root 13. And the answer was 8,45. Is that correct? Okay, so that was wrong. So it's going to be theta is equal to 8,4. As I said, I've entered that as a root 3 and not root 13. Okay. Okay, so let's look at number 2. Okay, so let's look at number 2. In number 2, we are told that the figure represents a triangular prism. A bit smaller. Okay, so the figure represents a triangular prism with AC equals AB, which is equal to 10, which is not on the diagram, so I'm going to write that in. So AC is equal to AB, which is 10. So this is an isosceles triangle being formed here, which in turn would make this angle equal to that angle. Okay? Then we are told that BAC is 70. BAC, angle BAC is 70. The question says calculate the triangle ABC, which is the area of the triangle. This is a non-right angle triangle, not so. So what do we need in order to calculate the non-right angle triangle? We need two lengths and an included angle. Not so. In this case, I have two lengths and an included angle. You see that? So the area of triangle ABC is equal to half AC times AB sine of angle A, which is the BAC. Do I have to write this here? No, you don't have to. Okay. That's simply half times 10 times 10 sine of 70. Then we are half times 10 sine of 70. It was an answer of 46,98. So 46,98 centimeters squared. Is that correct? Alright. Let's look at 2.2. The question says, take this off. Question 2, we are told to calculate the length of BC. So what do we notice here? We have that looking, there's 70, that is 10, 10, CB. So we have again two lengths and an included angle. So I'm going to calculate BC by using two lengths and included angle. Cos rule. So BC squared is equal to AC squared plus AB squared minus 2AC times AB cos of angle BAC. Okay. Again, we don't have to write this. Okay. So you're going to have 10 squared plus 10 squared minus 2 times 10 by 10 cos of 70 degrees. Okay, the calculator goes 10 squared plus 10 squared, we're going to say 2 times 10 squared minus 2 times 10 squared cos of 70. That gives me BC squared to be 131,5959713. The root thereof gives me an answer 11,47. So BC is 11,47. Okay. Any confusion there? Alright. We'll take this off here. Centimeters, of course. Okay. Then the next question says 2.3. Calculate the height of the prism. Calculate the height of the prism if CBF is 40. So the height of the prism is actually EF, not so. So you have a triangle looking like this. So that is BF, C, and this angle is 90, this angle is 40, this length is 11,4. So they want you to calculate CF, not so. So which trigonometric function uses opposite and adjacent, which is tan. So tan of 40 degrees equals CF over 11,47. Cross multiply, so CF is equal to 11,47. Tan of 11.47. Tan of 40 gives you 9,62. 9,62. Is that correct? Now the last question, or is there another one? The last one. Okay. Any confusion there? Right, let's carry on. That was number 2. This is of course now number 3. Okay, exercise 3, number 3. We are told that Zandi, is that correct? Zandi is standing at point X. She observes two vertical poles A and B. She observes two vertical poles AB and CD. Alright. The angle of elevation from Zandi to C, or from X to C, is 20 degrees, which is this angle here. Okay, and then from Zandi to A, which is 25 degrees, so X to A is 25 degrees there, And of course the distance between Zandi and the foot of pole AB is 15, and the pole CD is 5 meters then. The question says calculate the distance from X to A. So what should you see now? You see a triangle like this? This is the triangle I'm drawing now, okay? That's the triangle I'm looking at. So it's triangle A, B, X. What's the size of this angle? 90. And this is 25. And this is 50. They want you to calculate AX. So which trigonometric function uses adjacent and hypotenuse? Which trigonometric function uses that? So you say cos of 25 degrees equal to adjacent, which is 15, over hypotenuse, which is AX. Cross multiply, so I'll get AX cos 25 is equal to 15 divided by cos 25 both sides. So AX is going to be 15 over cos 25, which makes AX to be cos 25, it will be 16,55. 16,55 meters. Okay. Any confusion there? Okay. Right, so let's carry on with our lives. 3.2. Now we are told that calculate the distance from A to X to C. So in this triangle now, lying the side, CXD. I'm going to draw that triangle. Also note that I'm drawing it apart all the time so that you guys don't get confused. Okay, so this is C, D, X. So what's the size of this angle here? 20. This is 90. That is 5. So they asked you to calculate XC. So that is opposite and hypotenuse. Which trigonometric function uses opposite and hypotenuse? Sine. So sine 20 equals opposite, which is 5 over XC. So you can be cross multiply, so that will be XC sine 20 equals 5 divided by sine 20, so X equal to 5 over XC is equal to 5 over sine 20. So it's going to be 5 over sine 20 gives us 14,62. Did you see that, people? Yes, my girl? Yeah? I thought you were going to ask me something mathematical. Alright. So then 3.3, it says calculate the distance AC between two poles if AXC is 46 degrees. So what you should see now is two lengths and included angle. So which trigonometric function is that? Oh, so AC squared is equal to 16,55 squared plus 14,62 squared minus 2 times 16,55 times 14,62 cos of 46 degrees. You see that? So let's go. It's going to be the last answer calculated was 14,62. So it's going to be 16,55 squared plus answer squared minus 2 answer times 16.55 cos of 46. Also, so it's going to give you 151. So the square root there of square root of that answer, of course, gives you 12,31. So AC is going to be 12,31 meters. Is that correct? Okay. See any confusion there? Okay, so there's 7 sums. So I'm going to do 4 in the first video and then 3 in the second video. Alright, so let's look at number 4. Yeah, that's one. Right, so in the diagram, Amy and Bhuti stands 200 meters apart. There's Amy and Bhuti, which are in the same horizontal plane as D. So we're assuming this is the ground, the floor. What's wrong? Is there a question? Okay. Then we are told that they both observe the angle of elevation of balloon C from A and B to be 48. So if that is 48 there, Bhuti is also 48. Can you see that, people? Then the question says calculate the height DC of the balloon above the ground if CAB, this whole angle here, is 64 degrees. Okay, so they want you to calculate DC. You all agree with that? Okay, so looking at these two triangles here, what do you notice about triangle ADC and triangle BDC? What do you notice? Sorry? They're the same. The same what? Angles? Yes, so there's 48, 90, 90. Sorry? And I got the common side. Not so. So those two triangles are actually what? What? Congruent triangles. Not so. So triangle, ACD is congruent to triangle BCD. Why? There are two angles at the side. So angle, side. Our favorite one, huh? Right. So if the two triangles are congruent, people, then what can be concluded? Then you can conclude that AC is equal to, for those of you who don't see it, AC is equal to BC. Can you see that? CD is equal to CD, and AD, which is this line here, is equal to BD, which is that line. You see that, people? So why did I also have to go down this route is because you see here I have that length thing. You see that? So I would have to conclude that triangle first. Okay? To get the length of this side here, or that side. And then I use the triangle CDB. Can you see that, people? If you look at triangle CBD, there's nothing you can do here because we only have an angle. We only have an angle, we don't have that side, that's what you want to calculate, and we don't have that side. You guys understand why I'm going that route? I've got to qualify it, why am I going there first? Okay. So what do we say, people? We say that CA is equal to CB. Why? Because triangle ACD is congruent to triangle BC. You don't have to write the reasoning. Okay? So now, you see this is 64. So this was the size of CBA. It's also 64 degrees. Why? Angles opposite equal side. People, again, we don't have to say the reason here. It's not Euclidean geometry. Okay. That is 64 there. So now we can actually calculate this angle. Not so. So it's going to be ACB. ACB is equal to 180 minus 2 times 64, which is 128, which is 52 degrees. Why? Sum of triangles. In this triangle ABC. Okay, so this angle, of course, is 52 degrees now. Right, with this, remember that these lengths are equal. No? So how am I going to calculate, or what formula can I set up using two signs like this? Either sine rule or cos rule. As you can see, it's two sides an included angle. Or we can use sine of 52 over 200 is equal to sine of 64 over BC. Can you see that, people? Either way, you'll get the same answer. So, in triangle ABC. For those of you who don't see it, it should look like this now. No? You see those lengths are equal. This is a 64, 200 meters there. And this is, of course, AB. You guys see that? Oh, yes, and that is 52 here. So, according to the sine rule, what would it be? Sine of 52 over 200 is equal to sine of 64 over CB. Or I could have gone with AC. Okay. So let's carry on. This is number 4, no? So we cross multiply. So it becomes CB sine 52 is equal to 20 sine 64. Divide by sine 52 both sides, so it's 20 sine 64 over sine of 52. Okay, so it's going to be 20 sine 64. Sorry? 200. Okay, thank you. Why is that so late? But thank you for telling me before you don't tell me again. Okay, and that's over sine of 52. Gives you 228. Okay? So CB is going to be 228, comma 12 meters. Not so. Did I ever answer the question? No, the question was to calculate CD. So we will have a triangle looking like this. This is the triangle I'm drawing now. So that's CD, B, 48. This is 90, and we work CB to be 228, comma 12. Do we have enough information to do that calculation? Yes. So what are we saying? Which trigonometric function is opposite in hypotenuse? Sine. So sine 48 is equal to CD over 228, comma 12. Cross multiply, so CD is 228, comma 12 sine of 48. Then the calculator answer sine 48 will answer 169,52. Is that correct? Alright. Any confusion here? No? Okay, so I'm just going to stop the video and then I'm going to do the remaining sums, okay?